Today we're going to talk about topographic and satellite maps, and I want you to just take some notes on a scratch piece of paper that you'll keep in your science journal or your science binder. So this is not for you to turn in. This is something that you are going to keep up with, and it's going to help you as we move through this next week and a half with topographic maps and satellite maps. So a topographic map is a representation of a three-dimensional surface on a flat piece of paper. So it's like taking a mountain, right? And we're just flattening it, but we're still able to show all of those different points of elevation on the mountain. And we're just flattening it on a 2D surface so that you can see all of the points of elevation. Contour lines are going to be called level lines, and what they do is they join points of equal elevation on a topographic map. The further apart the lines are, the more level the land is. So if I have lines on a topographic map that look like this area right here is going to be more level. It's going to be easier for me to get up to the top of the mountain. But if the lines are closer together, that means I have a more steep slope. So if I have something that looks like this area right here is going to be a lot more steep, and it's going to be more challenging to get to the peak of the mountain. Contour lines are usually marked to show their elevation, and the amount of elevation between each line is called the contour interval. So when we look at topographic maps, we want to calculate the contour interval. Usually this interval is going to be given to us, but if it's not, we can just calculate it by seeing what the lines are counting by. So if I look at this particular topographic map that I have here, I've got 980, 1000, 1020, 1040, 1060. So I can see that I'm counting by 20, so my contour interval here is going to be 20. Not every line, though, will be marked necessarily. So oftentimes we see topographic maps that look like this one that we have here, where we have index contour lines. And these lines are going to be bold lines that will have an elevation. And then in between those, we'll have just the normal contour lines that are not going to be marked with a specific elevation. When this happens, we need to calculate what the contour interval is going to be. So what are we counting by? So to do that, we're going to subtract our two index contour lines that are closest together. And when we subtract 800 minus 700, we get 100. And then we're going to count all of the lines that we see going up to the next index contour line. So we have 1, 2, 3, 4, and then this fifth one. We want to make sure we include the one that we're counting up to. And then we're just going to divide that. So 5 divided by 100 is 20. And guys, we want to go ahead and check our proof here. We want to check to make sure that that makes sense. And so all I'm going to do is just label each contour line. So I have 720, 740, 760, 780, 800. So that does work and makes sense. So my interval for this particular topographic map is 20. So when we look at topographic maps, we can see landforms that are there, and we can also see rivers. So rivers are going to be shown on a topographic map by curves, and we can see this U-shaped, V-shaped curve going up the side of this, what appears to be a mountain. And so this is going to be a river. Rivers are usually marked with a dotted line, and the contours make a V shape or a U shape that points upstream. So here we have a picture of a satellite map, and a satellite map is going to be different than a topographic map because a satellite map is just a picture of the area from space, looking down on that area. It's not going to show us lines of elevation, so we're not going to be able to see how tall something is, but we can see the landscape of the area, and we can still predict changes to the Earth based on these satellite images. So this is a topographic map of Angel Island State Park. And remember that a topographic map is just a 2D representation of a 3D surface. And we can see points of elevation on this. We can see if there's going to be steep slopes or if there are more gentle slopes as you're moving up in the area, in the terrain. Okay, this is going to be the satellite map of that same image. So here we can see the water that's there. We can kind of see the sand and the deposits that are going around the island. That is something that we can't see on the topographic map. Both of these can be useful in predicting changes to the landscape in the area. Okay, so I want you to look at this topographic map at points A, B, C, and D, and I want you to decide where is the most gentle slope, where is the steepest slope, and where would the river be? Okay, so our steepest slope is going to be right here at A. If we look, we see these lines are very close together, and that means we're going to have a more challenging time getting up the side of this mountain or hill. But if I look at B, I see that these lines are going to be more spread out, and so this is going to be an easier path going up the side of this hill or mountain. And then where would the river be? So to find the river, remember we are going to look for that V shape or that U shape that kind of goes upwards. And so our river is going to be right here at D. Okay, on this image right here, we do see a topographic map, and this is going to be a top view of a topographic map. And then we also have the side view or the profile view. And both of these are showing the same thing. One is just looking from the top, looking down, and one is just looking at it from the side version. And when we look at these, we want to compare to make sure that they make sense. So I have a peak here that's a little over 50. I see here I have a peak that's going to be a little over 50. Here I have a peak that's a little over 40, and here I have a peak that's going to be a little over 40. So this side view right here does match this top view that I have here. And there will be questions that you'll see where you're asked to compare top views and side views, and so you want to make sure that they make sense. That is everything that we have for today on topographic maps. If you have any questions, please let me know.